Hello students, today we're going to be talking about triangle congruence. We're doing two more different theorems. One will be SAS and the other one will be HL. The first one stands for side angle side and the other one stands for hypotenuse leg. Please make sure you're taking notes as you go and you do the completion check once we finish. So before we actually get into the theorems, I want to make sure we knew what one key word is, which is the included angle. The included angle is important because we're going to be referencing two sides and an angle. So we need to know which angle we're talking about. Well, it's all going to depend on which sides. So in this specific case, if we're referencing side length AC and side length AB, the included angle is the one that's going to be right in between that. So in this specific example, it's going to be angle A. However, we have two others, and again, it's going to all depend upon which two sides we're talking about. So if instead we were referencing segment AB and segment BC, the angle was going to be angle B. But if we're instead talking about the side with segment BC and side with the segment AC, the included angle is angle C. It's very important that you know which one the included angle is, because that's going to be the difference between right or wrong. So now that we know the included angle, we have our side angle side congruence postulate, which says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then those two triangles are congruent. So in this specific case here, we're talking about segment AB is congruent to segment RS. We know that BC is congruent to ST, and the specific angle we're referencing is angles B and S. That has to be the angle that's in between the two sides that we're talking about. So why is it that we need to make sure we're having the angle that's in between? Well, let's talk a little bit about what happens if we were to use an angle that's not considered the included angle. So if we were to have two side lengths of the same and an angle that's not included, we could essentially create two different triangles. So here's our first example. So we have side AB and side BC is congruent to another triangle that has similar side lengths. And now we're talking about an angle that's not included. Well, what can really happen here is I can take that side BC and just kind of push it out. So what's really changing here is even though this side and this side is the same, and these two sides are the same, and that the fact that these two angles are congruent, what's really changing here is this bottom length AC. So this bottom length AC is able to change, and these angles are to change, and now we no longer have two congruent triangles. So that's why it's important that we maintain that this angle in between stays the same, opposed to any angle that's not included. The other type is with hypotenuse leg, deals with a right triangle. So I just want to make sure and review the key pieces to a right triangle, because if I reference hypotenuse and leg, you need to know which one's which. So just to remind you, in a right triangle, the two pieces of the triangle that make up the right angle are known as the legs, and the longest piece, the ones directly across from the right angle, is called the hypotenuse. So now that we know the pieces of a right triangle, our hypotenuse leg congruence theorem states that if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second triangle, then those triangles are congruent. So one thing I want to point out to you is just because we're dealing with right triangles, don't automatically jump to the hypotenuse leg congruence theorem. You have to make sure you're paying attention that we've got a leg and we have a hypotenuse for two different triangles. If instead we were to have two legs, it would be a different case. It actually would be a side angle side type of problem here. So you need to make sure that you're paying attention to whether or not we have ourselves a hypotenuse and leg, or we have two legs. Sorry about that. Okay, so in this one we do have hypotenuse and we do have a leg, and we need to make sure that the angles are right angles in there, and then we can conclude that the two triangles are congruent. So these problems are pretty straightforward. So what we're going to do is go through and do two proofs. So let's start with this first one. Let's go ahead and start our statements. We're trying to show that this triangle here is congruent to this triangle down here. So we always start with our givens. So our first given was that segment BC is congruent to segment DA. And the reason is given because that was told to us. We're also told that segment BC is congruent to, or not congruent, is parallel to segment AD, and that is also given to us. So why do we need to bring in the fact that something's parallel? Well, recall back when we had parallel lines, we have a bunch of different types of congruent angles or equal angles. We had the alternate interior, alternate exterior, same side interior, and the corresponding. So this is why we want to bring in congruent angles, because we can actually identify by the two parallel lines cut by a transversal, we have actually two pairs of, or a pair of angles in here that are congruent to each other. Specifically, we've got angle DAC is congruent to angle BCA. So this angle down here, angle DAC, is congruent to this angle up here, angle BCA, and what type of angles these are? Well, these types of angles are alternate interior angles. So they're congruent by the alternate interior angles theorem. Now, we don't have enough information here. We need either 3 sides or 2 sides at an angle. So the other thing is, whenever we have 2 triangles that are laid up against each other, you always want to bring in that third side. So we can now conclude that segment AC is congruent to segment AC, and we've talked about this many times. When you get the same thing on both sides, it's like a reflection. This is a reflexive property of congruence. So remember, in parentheses, we're going to put the congruence to make sure you know the difference between equals and congruence. Well, now let's analyze what we have here, if we have enough information. So we're going to go through and identify which each piece is. These 2 here are pieces of a side of a triangle. These 2 are angles, and these 2 are sides. Now, before I can just jump to the side angle side, which is clearly what we're going to be doing, you need to make sure that this angle here is our included angle. So let's focus on one of the triangles. Let's do the top one up here. We've got ourselves segment BC, segment AC, and we're talking about this angle here. So we see we have side, followed by an angle, followed by a side. So we can go ahead and conclude that the 2 triangles are congruent by side angle side. Now again, we just wanted to verify that that angle was the included angle. Let's do another one here. So first, let's bring in our givens. So we know that YZ is congruent to XZ. That's our given. And we know that the lines are perpendicular to each other, which is also given. So there's a couple of ways we can go from here. You can either start talking about the perpendicular lines, or you can figure out what else is congruent. So once again, like I said before, whenever you have 2 triangles on top of each other, you probably want to bring that in there. So in this case here, we see that YZ and ZY are the same line. So we might want to bring that in. That might be a good thing here. Now, even though these guys are written differently, those are still the same line. So we're still going to use the reflexive property of congruence. Sorry, I want to go ahead and make that change there. Okay, so why would I need to bring in the fact that things are perpendicular? Well, as you saw in here, that is showing me that I have myself right triangles. So then I want to identify what my other pieces are, because it's either going to be a side angle side or it's going to be a hypotenuse leg. So what is WY and XZ? What you can see here is that those are the hypotenuse of 2 right triangles. And then what is ZY and YZ? Well, that's another leg. So just keep in mind, just because it has 2 pieces of a right triangle doesn't automatically mean it's going to be a hypotenuse leg. It could be a side angle side. However, in this case, we do have the hypotenuse and the legs, so the triangles are congruent by HL. So all you need to do is write HL. One more example. You're making a canvas sign to hang on the triangular wall over the door to the barn shown in that picture. You think you can use 2 identical triangle sheets of canvas. You know that the segment RP is perpendicular to QS, and that PQ and PS are congruent to each other. So we want to know, what postular theorem can you use to conclude that triangle PQR is congruent to triangle PSR? So let's go and review what we have. Now, once again, I just want to make sure we understand that just because we have right angles does not automatically mean we use hypotenuse leg. Okay, just want to make sure we understand that. So we know that segment PQ and PS are congruent to each other. So this piece here, PQ, is congruent to this segment here, PS. And we also know that RP is congruent to each other. So we have a couple of options here. Let's first determine, due to the fact that the perpendicular lines, we know that it's right angles. So we needed to figure out, are we going to be using hypotenuse leg or side angle side? So let's analyze what pieces we're given. PQ and PS, those guys are legs to a right triangle. And what is RP and RP, essentially? Well, RP is another leg. It's not the hypotenuse. So in this case, I'm not actually going to be using a hypotenuse leg because I don't know about the hypotenuse. So instead, I know that this is a side, and I know that this is a side, and I essentially have my angle down here since they're both right angles. So these guys are actually congruent by side angle side and not hypotenuse leg. Again, just because we have right angles does not mean we're going to automatically run to HL. So at this time, if you have any questions, please write them down, bring them to class tomorrow, and do the survey that follows. I'll see you tomorrow.